everybody, I hope you're doing well and welcome to the platform of Codechef. Today we're gonna be solving the problem stacking pancakes. The difficulty level for this problem is easy and the prerequisites required are your dynamic programming. This is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try and understand the problem statement. Chef is good at making pancakes. Suddenly he gets request to serve n pancakes at once. He serves them in form of a stack. A pancake can be treated as a circular disc with some radius. Chef needs to take care that when he places the pancake on top of the stack, the radius of the pancake should not exceed the radius of the largest pancake in the stack by more than 1, and additionally, all the radii should be positive integers, and the bottommost pancake should have radius as 1. He wants you to find out in how many ways you can create a stack containing n pancakes. Okay, now let me just summarize the problem statement. The problem statement says that basically chef wants to initially arrange n pancakes. Now, the condition being that the bottommost is arranging it using a stack structure. So, whichever pancake that I'm pushing, that will go in the bottom, right? So, the bottommost pancake should have its radius as 1. Now, the also problem statement says that when he places the pancake on the top of the stack, the radius of the pancake should not exceed the radius of the largest pancake in the stack by more than 1, right? So radius of that pancake should not exceed the radius of the largest pancake in the stack by 1. So chef wants you to find out in how many ways you can create a stack containing n pancakes. Okay, so this is what the problem is asking, and in how many ways you can create the n pancakes if you're given these two conditions as your base conditions, right? So now this problem can be solved easily by the concept of dynamic programming. Also, the constraint n is less than 1000. We suggest some kind of 2D DP approach, right? So some kind of n square approach we can build to solve a problem in the required complexity. So this problem can be solved by dynamic programming. What we can do is let's denote our dynamic programming as dp of I comma j. So where my I denotes the number of ways of arrangement such that a stack of I pancakes has the maximum radius j. So basically the dp of I comma j denotes the number of ways of arrangement such that a stack of I pancakes has the maximum radius j. Here my I component denotes the maximum or the number of ways in which my I pancakes can be arranged such that the maximum radius in all of those pancakes is j, right? So firstly, we can write a recurrence relation of dp of I comma j as the following. Our dp of I comma j is nothing but sum of dp of I minus 1 into j times j plus your dp of I minus 1 j minus 1. Okay, so why so? Because this is so because your dp of I minus 1 into j is considered in the cases when you have placed the pancakes till size j in the previous position, and in those cases you can place any pancake till radius j in the current position. What you have done is, since you have already placed pancakes till size j in the previous position, according to the condition, you can place any pancake till radius j because we are not violating the condition of stack more than 1, and we're also satisfying this particular condition, so we can place any radius till j. The state becomes my I minus 1 is the previous stack or previous ways. We just simply multiply it by j because those are the number of ways in which you can place according to the condition. And then secondly, your dp of I minus 1 j minus 1 is the case when you are placing a pancake of radius exactly 1 less than j in all the previous positions, and you are allowed to place a pancake of radius j in the current position, right? So this is why we have taken these two states of dp, and this is how our dp of I comma j can be calculated using this recurrence relation. So after that, our answer is simply, since we want to calculate the number of ways in which the n pancakes can be arranged, so it is nothing but summation of all j with j less than n for dp of n comma j. That means my dp of n comma j basically denotes that this is the way to arrange n pancakes using the maximum radius of j. So what we do is we iterate for all radius between 1 and n, we calculate the value of dp of n comma j, and the base case being my dp of 1 comma 1 will equals to 1, right? Because there is only one way to place a pancake of maximum radius 1, like there's only one pancake that can be placed with maximum radius 1, and the number of ways to do is 1 only, right? So yeah, that is the answer, that is your base case. And after that, you can generate all your DP using this recurrence relation. So yeah, this becomes the approach to solve this particular problem. Now let us understand this particular approach clearly when you see the code for this particular problem. So let us proceed to the coding section. Okay, now let us try and understand the code for the following problem. So here we have initialized all our header files. Then in our main function, what we do is, firstly we initialize our dynamic programming array that contains the maximum constraints, right? So 1000 and 5005 are the maximum size of n that we can obtain. Then we initialize our mod value because at every time the question has told us to take the answer modulo mod. Then as I discussed in the approach section, our DP of 1, 1 equals to 1, because to arrange the stack size of 1 with a maximum radius of 1, there can only be one way, right? After that, what we do is we traverse in the entire array and then we compute our DP of I comma j as the two observations that I discussed. Firstly, your DP of I minus 1 comma j minus 1 and plus your DP of I minus 1 into j, DP of I minus 1 comma j into j, right? And then each step you take modulo. So for each and every observation where I took this particular state, I have discussed in the approach section, right? So you can go back and refer there. After that, your answer becomes simple. You just input a number of test cases. For each of your test cases, what you do is you input n according to the input format and you initialize your answer as 0. And then your answer for unranging up till n stacks becomes nothing but dp of n comma x for all the values up till 1 and n. Right? This also I discussed in the approach section that you have your the number of ways to arrange n stacks is nothing but your n stacks into the maximum radius of each type. So your n stacks with the maximum radius of 1, n stacks with the maximum radius of 2, n stacks with the maximum radius of 3, and so on. And you can output your answer for each of the test cases. Let us run our code on the sample test cases to check whether our code is working perfectly or not. As you can see, we got the correct answer according to the output format. So let us submit our code on the actual test cases to check whether our code works perfectly on those or not. Okay, as you can see, we got the correct answer verdict for the following problem. And yes, this becomes the right approach to solve this particular problem, right? So here, the entire problem was completely based on dynamic programming. Now let us discuss what are the mistakes people can make in solving this particular problem. If you try to solve this problem using any other approach in dynamic programming, then the implementation of the problem can become quite tedious and you might get a wrong answer verdict if you do not solution or if you do not find the solution of the correct logic. So this was the easiest way to solve this particular problem. So this is the learning you get from watching my video. I hope you like this video. Please like, share and subscribe to our channel. Thank you.